So last time we discussed about the loops and we discussed about the conditional statements. So, and we discussed about the methods, right? So how we can define the different methods. So today we discuss after that. Any doubt in this conditional statement and switch or loops? While, do while, for each, right? So last time we discussed about the arrays. So today we discuss more about these arrays, how we declare these arrays. So last time we use a for each loop with the array. So today we discuss about that one in elaborated form. Then we discuss about the methods. So methods are of different types. We discuss the different types of methods. Now, today we discuss about methods are declared in a class or a structure by specifying the access level such as public or private and optional modifier such as abstract or sealed and return value. The name of a method and any method parameter. These parts together are a signature of a method. So last time we discussed about the method signature. Method signature. So method signature, what it contains? First, it contains method name. Second, it contains return type of a method. Third one, we can specify the access level of a method. Then, number of parameters. And fifth one, type of parameter. So right now I give you an example. First one, here I declare a method as a public void my data. This is the first method which I declare inside a class. Suppose this is the program class, and inside this class I declare this method. Right now this is my first method. Then after that I declare another method, private void hello string name. And suppose right now I'm not defining a body of this method. Then public string add string first name, f name I define, string l name, and this one. So now in this location I want to check the method signature. So what is the signature of a first method? How we can define that one? So right now my first method name is public void my data, right? So I have to define a signature for this one. So right now I copy this, Control C, and suppose I have to define a signature here. Now, first one, what is the name of this method? So that method name here is my data. That is the method name. What is the return type of this method? So this method return void. Void means null or nothing, right? So here return type is nothing. Void always return, void never return anything, right? Void means nothing. So we are not returning anything. Access level, public, that is the access level. Means this method can be accessed within the another class, right? Outside of this class. So here access level is public. Then number of parameters. Parameter we define within this bracket, right? So right now this bracket is blank, means there is no parameter. Or we can say 0 parameter. Then type of parameter, right now 0, so not applicable in this section. So this is the signature for first method. Now same thing I have to do for this second one, hello method. So here I paste it. Now I have to define a signature for this one. So what is the method name? That is hello. Return type of this method, again nothing, it's void. Access level, that is private, means it is accessed only within the class in which I specify this method. Then parameter, how many parameters? There is one parameter, that is of name. And what is the type of this parameter? That parameter is of string type, right? Same thing we do for the last one. The method name, that is add. Case sensitive, so you have to define in the same case. Return type, so here this method return string value, right? Because here its return type is string. So return type here is string. Then access level, that is public. And number of parameter, how many parameter? 1 and 2. When we define a more than one parameter, we separate those parameters by using comma. So first parameter is f name and second parameter is l name. The number of parameter here 2, and type of parameter, both are of string type. So suppose first one is a string and second one here, for example, I define as a suppose integer. You can define anything, right? Integer, first name, and after first name I want age, for example. So here I have a two parameters. One is of string type, second one is of integer type. After that I define another parameter in this. So here string and name, for example. So right now how many parameters? 3, and 3 parameters. So what is the signature of the last one? That is of string type. So this is the method signature. So method signature contain method name, return type, access specifier, and number of parameter and type of parameter. So last time we discussed this one. Now we can declare these methods within the class or structure. Let's see. Here I create a new project. Right now I create a method within a class. After that I create a method in a structure. Class. I remove these extra namespaces. Here, first of all, by default, the default method which is defined in a console application is the main method. So main is the method which runs the program in console application. So this is a single method which contains entry and exit point of an application. Means when I run my application, so when we run our application, so our application first go in a main method. After that, it calls rest of the methods, right? So right now, in a class we discussed about how we create a method within the class. Right now, I show you two methods. So here I create a public. So when I declare a method within the same class, so no need to declare public or private. You can declare your method directly like this. Add into B. And here I declare variable int C. C equals to A plus B. And console.writeLine C. This is the first method. Here I declare second method. For example, public string merge, or you can say concatenate string name string. Now, this method return a string type. So in this location, we have to define a return keyword. So when a method contains with any other data type rather than void, so in that location, you have to use a keyword that is the return keyword. And after this return keyword, you can define like this: fname plus. I have to return. Right now, next one. So in this location, what I did, I declare my methods. So this one is called as a method declaration. Now, after method declaration, we have to call these methods. Where we call these methods? We call these methods within the main method, right? So right now, where I declare this method, these methods I declare within a class. That class name is program. First of all, I have to declare object of program. P new program. So in this location, I create instance, or we can say object of a class, so that we can call class members. Right now in this class, add and merge are the class members. So I have to call add and merge methods. So I declare this instance p dot add, and here I define int a, value of a, that is 10, value of b, suppose I define 5. Right now I have to call second method. So this is called a method calling. This statement is the method calling. In this location, I call my method. Now, which one is the second method? That is the merge. So here I use p dot merge, and string values I have to define. Here I define and last name. This one. Now, this method returns a string value. So here I have to store a result of this method within a string type variable. Here I declare variable name result, and this in this result, whatever the result of a merge method, I put it in the result. Then after that, console.writeLine, here I use result, because this method return a string value. So return function it returns something. So I have to store that result of that method within a variable. That variable name is a result, and after that, console.writeLine display the value of that result. Here I put a breakpoint on this line, not on this one, this one, and now use F11 to run this. Right. First, where my cursor go? My cursor go in our main method. So main is the entry point of application, entry point of a console application. When we run our application, first of all, program go in our main method. Now, first of all, where it go? It go in the first line. It create an instance. It create an object of program class. Now, after that, second statement is p dot add. So now let's see where it jump. Value of a is 10 and value of b is 5. F11. So now my cursor directly jumped to add method, and let's see the value of a. Value of a is 10 and value of b is 5. Now F11, C, a plus b. So right now the result of c is 50. So here, because it's a void method, so directly I define a console.writeLine in this location. Then here in this location, you see it return a value that is the 15. right? So right now this is, I expand this one, class method. So we can see this result only in the console window. Now F11 merge method. After that I call merge method. So merge. What is the F name? F name is Peter and L name is Barker. So here this one, and let's see F11. What is the result of this one? Here in the result we got this result Peter Barker. But after that I have to display that result. So using console.writeLine we can display our result in a console window, right? So that's why here I declare console.writeLine to display that result. So here I show you that one, Control F5. This one, right? So this is the way to declare methods. Now next one, right now this method is void type. Suppose here I create another class after this program, or in this location I call these methods by using P program instance. Suppose I don't want to declare this one. I don't want to call with the help of P. So in this location what we can do, here in a main method you see keyword static. We use the same keyword static, and here public. In this location we can use static this. And now let's see. When we use a static, so no need to create class object. You can call your methods directly without using class object. So static means you can call method or class members without using class object, right? So when we declare a method, before this method I declare a static. So right now no need to define this statement. I can call my method directly, right? Right now I show this result. Result is same, right? So it's your choice. You want to declare a static keyword or you don't want to declare a static keyword. Right now here I just want to explain that, like static, why static is declared here. Static means we can call class members without using the class object. Now next one, here suppose I create another method, that is class my new class, and within this class I create one of the method void and after this here I create another method within this class. This is public void string name. And then name. These two methods I declare. Now I have to call these methods. So from where we can call these methods? We can call these methods only from the main, right? And this main is declared within the class program. So first of all, what I have to do? I have to declare object of this class, right? So in this location, I want to call that. So I declare object, my new class, mn new text. I create instance of a class so that I can call a class member. Now, how many members are there? There are two members. So here I use mn dot. Can you see the hello method here? Within the intelligence, that hello is not visible. I can't see hello here. Which method I can see? I can see only welcome, right? So here I click on welcome, and there is one parameter. Here I define Smith. Right. Only one method is visible, but hello method is not visible. Why? Hello method is not visible because this hello method is private. So private means you can access only in the same class. You can access this method only in this class. So how can I use it in the another class? So what I have to do? I have to make it as a public so that I can use this hello method within the second class if I really want to see that. Right? So here I go to this location and again I type and then dot. Now here you can see like this. Control F5 and here is the result. Right? Any doubt? So why I declare public and private? So when we have to use public and private, right? So in this location, suppose you want to share your information with another class, at that time we use a public. Otherwise, we can leave it. So by default, this is a private. Or otherwise, I can write a private keyword myself. So right now here I write a private. So you see that hello is red in color, error. So here you read that error is inaccessible due to protection level, because that method is private, so I can't use that method within the another class. So I have to use that method in another class. I have to make it as a public. Now I can see that hello method here. Any doubt? So now we jump to the next one. Next one is the structure. How we declare a method within the structure. The structure is same like a class. In last classes we discussed about the value type and the, like we discussed about objects. Right now here I show you that one. Program. Now here I have to declare a structure. So when I declare a structure, here I use MS Paint. So in this one, in one of the class we discussed about this. Like we have types, object. Make it bigger. Okay, first of all I type it. Object. So object is a collection of a different type. Right? Within the object we have the value type, and second one is the reference type. So value type are further divided into parts. Pre-defined and next one is the user defined. Predefined means which is already defined by the Visual Studio, and user defined in which we define it ourselves. So the predefined value types are different data types like integer, float, byte, char, sbyte, long, decimal. All these are the value types, right? Boolean. So these are the predefined data types. Then user defined. User defined data types are structure. We discuss about enumeration, enums. These are the user defined data types, right? In which we create our own types. Then in a reference type contains class, our string, that is an example of a reference type. Then delegates, interface, right? So these are the example of a reference type. So object is what? Object is a collection of a different type, value type and a reference type. So in a value we have predefined value type, means which is already defined by the Visual Studio. And second one is the user defined. Structure and enumeration are the user defined. And in a reference type we have class, string, delegates. So right now here I declare a structure. So when we declare a structure, we use a struct keyword. Declaration of a structure is same like a class, but here we use a struct keyword, and structure is stored in a stack memory. Value type, where these value types store? Value types store in a stack memory. Whereas reference type, so the difference is only in their storage, heap memory. Right? So stack memory, in which information is stored in last in first out. It follows stack pattern. Here information is stored randomly, like in array. So now structure, and here I declare about employee, any structure name. Then within this structure, I define a method, public void full name, and here I declare string, f name, string, m name, middle name, string, and name. This is the first. These three parameters I declare, and here I use full name is, and here I use f name plus, and I define space in between that, and name plus, and like this. Then after this I declare another method, suppose string, and address. So int house number, string, street number, string, city, for example, this one. And when we use a string type, means it's return a string value, so here we use a return keyword. Now here I return house number, and I put a comma in between that. If you want to put it in a separate line, you can put it in a separate line, slash input, or otherwise street number, here, comma, and I put a slash in. City is on the next line. Like this. Now I have to call this employee methods. So how can I call? So first of all, they reduce the size a bit, 120. So this is the employee. I have to call it in the main. first of all, for this structure, again I have to create an object. So what is the structure name? Employee. Here I declare EMP new employee like this. And here I use EMP dot. First of all, full name. Full name is visible here, but address is not visible. So why that address is not visible? In this location, I can't see address because that address is private, right? So private means I can use only within the same structure. I can't use that private within the another class or in another structure. So how can I use the address here? So I have to make it as a public. So here EMP dot full name, and in a full name there are three parameters. Dot. For example, first one, then dot, and then this one. So how can I use the address here? I make it as a public so that I can see that address. Now EMP dot address. So this address return a string value. So I have to declare a string value for that. First of all, let's store house number. So suppose here I declare house number 102, street. Here I write street number 2 and city is that. It returns string, so I have to declare a string value. Add, for example, console.writeline add show that add this one. Now right click, set as startup project, and control F5. So here you see full name r.m.smith, and second one is the address 102, street number, and city is on the next line because I put the slash n in that location. So slash n means in new line I want that result. Like this way you can display that value, right? So this one is clear. So we can declare a methods within the class or structure, and we can specify access levels such as public, private, or optional modifiers, and return type so that it return a value. So return type of a method is not a part of a signature of a method for a purpose of method overloading. We discussed about this method overloading right now. I show you what is the method overloading. Overloading means same method declared multiple times. Right over here I show you the new project. In this location, I declare a method. Suppose void add. I add two numbers. This one. Now, again, I have to declare the same method, but I have to add three numbers. Right. So right now, I copy this method. Same method name. but signature is different. Method name is same. Here I add another one, int y, and I add 3 numbers in this. So addition of 3 numbers. That is same. Again, I want to add 4 numbers. Control V. So here you see my method name is same. Int x, int y. This. And last one, int p, int p, this addition of 5 numbers. Now, so same method. This thing is called as a method overloading. Means here I use the same method name, but here signature is different. Signature is different in each method because here I define 2 parameters, I define 3 parameters, 4 parameters. Suppose I define method with same signature. So in this location, my compiler should be an error message. Suppose right now same method I copy, remove this y. Let's see. First of all, I build this. Right click, set as a startup, and in this location compiler, when I call this method, so the way of calling this method, first of all I have to create a class object. So what is the name of my class? That is the program. P, new programs, and here I use p.add. Right. So in this location you see there are this one of 3. This add method declares 3 times. One with 2 parameters in that, next one with 5 parameters in that, and next one with again 2 parameters, right? 4 parameters, 5 parameters, and 2 parameters. Now I want to see this one 10, 30. This one. Now here I run this. First of all I build this. In this location it. Okay, show an error message. This add method with same parameter type. In the above code I declare add method twice. One is this one and second one is this one. So I can't declare same method with same signature again and again. In this location I have to change the signature of this. Int y and y. Now let's see, build. Now this program is successful because you can't declare same method name with same signature. In a class, it allows you to create a method, but you have to change the signature of that method. Signature, how you can change? You can change by defining it with the different parameters in that. Right? Number of parameters you have to change in that. So right now here, this is the first method with 2 parameters. Now I have to call second method with 3 parameters, 1, 2, 3, like this way. Same method with 4 parameters, like this. Now I run this program, Control F5, so all these are working. Addition of 2 numbers, addition of 3 numbers, addition of 4 numbers. Right? So this thing is called an overload. Overload means same method, but the role of that method is different in all the functions. Different in all locations. So first add method, it add only 2 numbers. Second add method that add 3 numbers. Third add method that add 4 numbers. So same thing happen in our life. For example, we can take a real life example of a human being. Like for example, you in your family you are as a son, or for example your work as in your company as an employee, right? So your role in different location, that is different. You are the same person, but your role is different in different places, right? So same thing in this location here. First add method, that the role of this add method is to add only 2 numbers. Role of the second add method, name is same, but here it adds 3 numbers. Here name is same, but it adds 4 numbers, right? So this thing is called as a overload. Same method name, but the role of this add the method is different in different locations. Clear? Now again I declare add method, control V, and here I change this parameter type, float. One is float, right? And yes, so here I declare it a float type. Float a plus b, right? Addition of 2 numbers. Now let's see, is this working? So p dot add. Now in this location, this method is working. Why this method is working? It also takes a 2 parameter, and this first one is also taking a 2 parameter. But here signature is different. First one is of integer type, and second one is of float type. So now in this location, when your parameter is of different type, so in that location this overload method will work, right? So here I show the result. This addition of 2 numbers, first one addition of 2 numbers are 40, addition of 2 numbers are 107.56, because signature is different in both the locations, right? So you can declare a same method with same number of parameters, but your parameter type should be different, right? If parameter type is same, in that location it will not work. It shows that this method is already declared. But when you change your parameter, so in that location it will work. So here again I change this to float, right? So now in this location it works, right? So here this is the void add, same way I add void add string first, string last, console dot write line. Here I declare string full name, and here I use first plus last. In between that I put a gap like this, and here I use full name like this, right? So now here I have to call this. Signature is different because both of these parameters are of string type. So here I use p dot add this one, and here I use Vishal laptop. This. Now it's working fine. Control F5. This one. Right? So 2 parameters, but the parameter type should be different. Then in that location it works. So this is called a method overloading. So here I use the same method, but I pass different values of different parameters on that. Right? So any doubt in this one? Method overloading. So however, it is a part of a signature of a method when determining the compatibility between the delegates and the method that it points to. So we discuss about delegate later on. But right now this overloading is clear. Any doubt in this overloading or structure? So method parameters are enclosed within a parenthesis and are separated by a comma. Empty parenthesis indicated that method requires no parameters. Method access, calling a method. So how we can call a method? We can call a method like this way, p dot add. So this is called as a method calling. And above statements are called as a method declaration, where I declare my method. So calling a method on an object is like a accessing field. After the object name, add a period and name of the method and parenthesis. So this thing, object name means class object, then period means this dot, and method name, then parenthesis, and within this we define the number of parameters, values of those parameters. So arguments are listed within the parenthesis and separated by the comma. So here these values are separated by comma. So method parameter versus argument. So method definition specifies the name and type of a parameter that are required. So in this location, when I declare add method, p dot add. So here you see it show me 1 of 6. Means this add method declares 6 times within the same program. So there are 6 method signature for this add method. So first one you see float A, float B. That is the first signature. Now I click on this. Second one is int A, int B. Same method name but parameter name, parameter type is different. Next, string first name, string last. Int A, B and Y, right? So here you see this add method declared 6 times. Now fifth type is int A, int B, int X, int Y. And last one is int A, B, P, Q and R, right? So this is the method signature, different types in that. So when calling code, call the method and it provides a concrete value called argument for each parameter. So which method you want to call, you have to specify a complete value along with that method. So right now I want to call like 1, 2 with 5 parameters, 3, 4 and 5. This one, right? Suppose I define with 6 or 7 values. Let's see, 6 and 7. Is there any method which contains 6 or 7 parameters? No. Automatically my compiler, in a compile time, it shows me an error message, right? Means the error message is it takes 7 arguments. So there is no method which contains 7 arguments or 7 parameters. So here I have to remove that. Now in this location, this one is working fine. Addition of 5 numbers are 15. So the argument must be compatible with the parameter type, but the argument name, if any, used in the calling code does not have been same as the parameter name defined in the method. So argument that could be anything. In this location, you can, here I use 1, 2, 3, or otherwise I can use different types. Int A, B, C, and here I define value of A is 1, value of B is 2, value of C is 3, right? So in place of 1, 2, 3, I can use A, B, C. These are the arguments. I can use any argument. By default in that location A, B and Y. So in place of Y, I use C here. It doesn't matter for that, right? You can use any value in there, any parameter, any variable in that location. But result is same. So calling code does not have to be the same as a parameter name defined in the method. So whatever parameter name you define in the method, at the time of calling, you can define any other method for that. Now, pass by reference and pass by value. By default, when a value type is passed to a method, a copy is passed instead of an object itself. So therefore, changes to the argument have no effect on the original copy or in the calling method. So you can pass a value by type by ref using the ref keyword. So when an object of a reference type is passed to a method, in a reference to the object is passed, that is, the method receives not the object itself but an argument that indicates location of the object. So in our last classes, we discussed about this reference type and the value type. So right now I show you this example again. Right click, add new project. Reference type sample. So main difference you can see only at the time in the memory location, because reference type that is stored in a random memory or heap memory. So in this location, I create a public void and change value. For example, here I use that int x, or in case of this, I use suppose change the value of x to y, y to x, and int y. In this location, actually what I want to show you, pass by reference, we use ref keyword. Declaration and column. So swap means here value of x is suppose 10 and value of y is 20. So what actually I want after swapping, value of x should be 20 and value of y is 10. So how we can do that? So in this location, either we can use a third variable and we can assign a value of x, like here I use temp variable, temporary variable, and in that I assign a value of x, right? So right now I assign value of x in a temp. Now after that, x in a x I assign the value of y like this, and in y I assign value of temp, something like this, right? So this is the one way. Second one, we can use plus or minus. So here we can use x equals to x plus y. One way is this one. Now within this x, what can I do? I can use x minus y, right? So x plus y means right now the value of x is 30. Now after that, what I did here, x minus y. So right now the current value of x is 30 minus, and value of y is 20. So 30 minus y, I have to define y equals to x minus y. So right now the value of x is 30. 30 minus, that is 20. So value of y in this location is 10. And next one, x equals to x minus y. So here we can do like this. Value of x is 30. 30 minus 10. So value of x is 20 in this location. Right. So like we can use either third variable, or otherwise we have a second option is plus minus. So let's do this one. Use a third variable first. Here I use the ref keyword for reference type. In this location I declare a temp variable, temp, and this temp I assign value of x, and in x I assign y, and in a y I assign this one. Now here within this main I declare two variables, int a I assign 10, int b. These are the normal values. This one. And first of all I show the value of a and b. Before swapping, value of x, that is Now same thing, values. See, now here I call a method that is swap method. So first of all, I have to create an object of my class. In this location, I use program A, new program, and in this location, I use p dot swap, right? And in this location, I use ref keyword, reference of A and reference of B. This one. Now here I see the value. So before, and this one is after swapping. After swapping, you see the value of A and B. And here I set it as a starter project. So before this, value of A is 10, value of B is 20. But after swapping, value of A is 20 and value of B is 10. Right? So in this location, reference A and B. So here is the memory location, and within this, suppose A that is stored on this location and value of A is 10. And for example, B is stored on this location and value of B is 20. Right? So here, this is the A which is pointing to this memory location, and B is pointing to this one. So A and B values 10, 20. Now X and Y. So here when we use this variable, so after that X and Y. X is also pointing to this one, 10, and Y is pointing to 20. So this one is before swapping. But after swapping, what it do? It changed the value of A. Value of A, what it did? It changed the value of A as a 20. So in this location, actually, here I cut this. It cut that value, and here it changed the value of A with 20. So it do changes in the actual memory location. And again, it cut the value of B and replace that value with 10, like this. So it modified the original memory location. Right? Both the variables are pointing to the same location, but when we do changes in that, so the changes will be produced in the original one. But in case of a callback value, same function I call without reference. So right click here. So I call the same one. Control C and paste it here and select this one. Remove this ref keyword. Right. So in this location I use pass by value. In a pass by value, this values remain same. Right click, set as start a project. Result is same in both the locations. Actual difference in this location is A. The value of A is 10 and B. Value of B is 20. After that, I assign that value in X. So value of X is 10 and value of Y is 20. So it creates a duplicate copy in pass in a value type. Create copy in memory location. Whereas in a reference type, it's pointing to the same location. So we can't see this difference actually, right? But in a normal term, in a term of memory, so we can say these variables A and X both are pointing to the same variable in the same memory location. But in case of X and Y, so here if we take a memory address, so actually this value type is stored in the stack memory, something like this, and here this. So like this. Here is A and value of this A is 10. Here is B, the value of B is 20. Same way, it creates a copy of X, value of X is 10 in the beginning, and value of Y is 20, like this. Right? So it creates a duplicate copies of that one in case of this value type, right? So before swapping and after swapping, it changed those values. The result in both the cases are same, but only difference in the memory location. Value of B is 10, value of B is 20. So value of A is, again, after that you see the value of A is 10 and value of B is 20 in this location. There is no changes in this location, right? So means that is pointing in the same location, but in case of a reference, that is a different one. Here I run this program, pass by reference type, set as startup, control F5. So a value of A is 20 after starting, and value of B is 10, right? But in this pass by value, right click, set as startup. This value of A is remain 10 and value of B is remain 20. That is the difference in a pass by value and a pass by reference. Right? So this one is clear, pass by reference and pass by value. So when we use the pass by reference, we use the ref keyword along with them. And in the pass by value, no need to define any ref keyword. By default, methods, by default arguments are passed by values. So return type. Return type means here in this location, return type of this method is void. Void means it doesn't return anything. If I define a string or integer, means it return a single value, either integer or string or whatever we define. So method can return a value to a caller, and if the return type, the type listed before the method name is not void, the method can return the value by using the return keyword, right? So if we have not defined a void keyword, so it return a value whatever we define in that. So a statement with a return keyword is followed by a value which matches the return type and will that value to a method call. So return keyword also stop the execution of a method if return type is void. So suppose with a void I define a return keyword here. So in this location, this will show an error message. Reference, right click, set as startup. I'll succeed it. Okay. Control F5. This one is working because this return doesn't return anything. F5 is fine. Return in value of 10. Let's see. In that location, so since reference types were return void, a return keyword must not followed by the object expression, right? So you can't define return keyword with void type method, right? So in that location, it show you an error message. So if return type is a void, return statement without a value is still useful to stop the execution of a method. So without the return keyword, the method will stop execution when it reaches end of the code. So method with non-void return type required to use the return keyword to return a value. So in the previous examples, we did this one. Like here, string, right? So in that location, it return a value. We use return keyword with that. With a void, we are not defining a return keyword. So return normally show you end of the program. The next one is the async method. By using the async features, you can invoke a asynchronous method without explicit calling back or manually split your code across a multiple methods or lambda expression. Async feature are introduced in Visual Studio 2012. So if you mark a method with the async modifier, you can use the await operator of a method. When control reaches the await expression in the async method, control return to the caller and progress in the method is suspended till await task completes. So this async and await method work when we have some background task. For example, I have a method which takes, for example, 15 minutes to execute that particular thing. Because sometimes here you see, like in a task manager, this time, control shift escape. Within this task manager, there are so many services which is running in the backend. right? There are so many applications which is running in the background. This one. So here, services. These are the services which is running in the backend. For example, W search or window defend, and there is visual ETW services. These are the services which is running in the background. So these services are required to run the operating system application, to run an application which is currently working on my system, right? So suppose I have big, I create a method which is more than thousands or more than 50,000 line of code. So obviously it will take a time to execute that program. So those lengthy programs, basically what we do, we put it in the background task. We put those methods in a background. What we do, we want that those programs are running in the background, and in the front end I can work what I want, right? I have suppose 50 small methods. I want to run those methods, and the big method which I want to run in the background. For that we use this await and async method. So await and async method basically useful when we have a very big method which take a long time in execution of that program. So those methods are defined in the backend process. So previously, before 2012 of Visual Studio, there was a background worker class. So that background worker class do all these things. But after 2012 onwards, Microsoft introduced this keyword, async and await. Async means asynchronously I want to run that particular method in the backend. The method which is very long, which take a long time in execution process. So async method control return to the caller, and the progress in the method is suspended until await task is complete. So when a task is complete, execution can resume in the method. So async method can have a return type, task, t-result, task, or void. So void return type is used primarily to define event handlers, and then a void return type is required. An async method that return a void cannot be awaited, and the caller of a void return method cannot catch exceptions that method throws. So by default here they show the example defining body definition. So it is common to have a method definition is simply return immediate with the result of the expression that have a single statement as the body of the method. So in this location they declare how we declare a method, right? So we can declare a method like this: public point move int dx dy, and new point x plus d plus x dx plus y. So like in this method they define different statements in that. Whatever we did in this location, the same information they define in this format, right? So few of the things we done after when we have actually these type of statements. Right now we discuss about the method. Async and await we will work when we work on the background worker class, right? Because right now if I explain you that async and await, that makes complicated, that create a complication in this location, right? So we will explain async and await. I will explain async and await when actually we work on the background processes, right? So till now we hold that particular thing. So this is the example of a method, how we can create a method and how we can call those methods. Sorry, like same, but I show you in this example. So express body define. So these are actually the lambda expressions. Those lambda expressions we do when we work on the delegates, right? Right now these are the examples. Like here you see double this equal sign and this. These are actually the lambda expression, and the way of writing a lambda expression is different than this thing, right? So when we work on the delegate, at the time I explain about there is a separate topic for the lambda expression. I explain about this one first because this is the complicated thing. First of all, I have to explain how we use those lambda expression within the variable. If I explain you directly in this location, so might be this will confuse you, right? So we will do this later on. Next one is the iteration. Iterator, last time we discussed about the loop, while loop, do while loop, for each loop. So what it do means where I have to perform repeated things like one. After that one, I have to display a series up to 30, up to 50. So that thing is the iteration, means repetition. Increase those values by one and display me the next generated value. So same thing we can do with the help of a yield return. So an iterator performs a custom iteration over a collection such as a list or an array. An iterator uses the yield return statement to return each element one at a time. So when a yield return statement is reached, the current location in a code is remembered. Execution is started from that location when the iterator is called the next time. So you can call iterator from a client code by using for each statement. The return type of iterator can be I enumerable that type T, I enumerator or I enumerator type T. So actually this yield keyword is basically it works with a for each loop. Last time we use an array with the array we use a for each loop. So along with that, we can use a yield keyword also. Method overloading, that one is done. Okay, right now I show you this one. So in this location for example, I create a method like yes. Can you see my screen? Okay. Now I minimize this. Here. Serial number I initialize with 0 and in number is at so 1. So in this location I use loop while it's number here I um, use return number. Actually, in this location, what I do, I generate a power 3 raised to power 2, that is 9. So something like that type of result, right? So in this location, I use a yield keyword. So when we use a yield keyword, along with the using a yield keyword, we have to use enumerable type, right? Because in this location, you see here. So the return type of an iterator can be enumerable of type. If this t denotes for this one, either it's integer or float or whatever. So this is of integer type. Otherwise, it return a enumerator. So when we use a real yield return, so with the yield return, we have to define these types, right? Enumerable, enumerator, and all these ones. Now here I create a method. Method name is calc power, and I pass a 2 parameter, number and exponent of that one. Now I have to call this method within the main. So at the time of calling this method within a main, here I use, because this yield is used in the for each loop, int item, or suppose that is int. Name of my function is calc power. This is a static type, so no need to create a class object. So we can call this function directly. Calc power, and here I pass 4, 3. This. Then console.writeLine, and in this location I just store values. Console.writeLine footer. Enumerable. Control dot system dot connection dot generate. We need this namespace because enumerable is actually a predefined interface. We discuss this interface later on. This one is the predefined interface, which here I show the definition of that. Go to definition. So this is the predefined interface, which is already defined by the Visual Studio. So when we use a yield return, so that yield return automatically return enumerable type data. So here, this is the enumerable type. We have to define that one, right? And this enumerable type is inherited by the enumerable type, right? And actually, this one is defined in a system.connection.generate namespace. So that we have to declare in this location. So right now I close this one. Again I build this. Now this one is successful, and here I run this. Control F5. So 4 raised to power 2, that is 16, and 4 raised to power 3 is 64. Right? So first one is 4 raised to power 1, that is 4. 4 raised to power 2, that is 16, and 4 raised to power 3, that is 64. If I increase that raised to power, so here I define up to 3. If I define up to 4, let's see. Control F5. So 4 raised to power up to 4, that is 256. Right? So this one is about the exponent. So I want like raised to power of that 4 up to 3 or up to 4 or up to something. So suppose here I use 2. 2 raised to power up to 7. Control F5, like this. Right? So something like this you want to generate. So in that location we use the yield return. So yield keyword basically used with a for each loop, right? So you want to increase the performance, at that time we use a yield keyword. So yield keyword basically help in the looping concept. When we are using a for each loop, at that time we can use a yield keyword. Otherwise, in few locations we can use a yield keyword, but you are comfortable with the yield keyword, you can use that one. So in that location, it return a enumerable type data that you have to define in this location. So now let's see this one. So an iterator perform a custom iteration over a collection, right? So you want to perform on a collection like 2 raised to power up to 8, 2 raised to power up to 10. So in that location, we normally use the iterator statement, right? So that an iterator use the yield return statement to return each element one at a time. So at a time we do 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, something like that. So when a yield return statement is reached, the current location in a code is remembered, and execution is restarted from that location when an iteration is called the next time. So now in this location, when I run, should return the it show me like first value 2 raised to power 1 is 2. It remember that one. Then 2 raised to power 2 is 4. 2 raised to power 3 is 8. 2 raised to power 4 is 16. So it remember the previous value. It show you the previous value. Then it jump to the next one, right? Uh, That's it. So execution is restarted from that location when the iteration is called the next time. So you can call a iterator from the client code by using a for each statement. The return type of an iterator can be IEnumerable, IEnumerable T, or IEnumerator, or IEnumerator T type. So there are 4 ways we can use a method parameters like optional, use parameter array, method overloading, specify parameter default. Parameter array we use when first of all when we declare the array types. Right? After that, we use a method parameter.